Hello, and welcome to your first video where we're actually going to talk about chemistry. We have spent so much time on dimensional analysis, and I know you don't think it's important, but I promise you in about a month or two, it's going to be super important when we start talking about how mixtures actually come together and how we actually make different solutions. So I promise dimensional analysis is not gone, but we're just going to move forward. I want to go ahead and start by mentioning that I have yet to define chemistry to you. And so in this video, I'm going to make sure that you understand what chemistry actually is and how we further classify it. I would say one of the hardest parts about this class is just being able to successfully classify different compounds and different mixtures because it's so easy to mix things up. And because we can't see everything on a macroscopic level, it becomes very challenging to identify, and not only identify, but be able to predict what's going to happen because we don't know what atoms are going to do. I mean, two liquids could look clear and we mix them together and they could cause some serious things to happen. So again, a lot of things in chemistry are studied on the microscopic level. And so we're going to talk about what that looks like, what's actually going on the atom level and what elements are doing and how compounds are made. I did not include an objective slide with this. I think we'll be okay for this video to not have an objective slide. If that really bugs you, just let me know and I'll let you know what we're supposed to be studying in this class. All right, let's go ahead and define chemistry. This video is pretty short as far as slides go. I do have quite a bit of information to tell you, but I did kind of chunk it down to just 2 slides. And I did that because I know you really don't want to hear this, but I wanted to make sure you understood, like I want to avoid having all these words on the screen and really just talk about your notes when we're in class together. And just kind of talk more fluidly about chemistry. I don't really want to read off the slides anymore. So that's why I'm doing it this way. Sorry, it just took 30 seconds of your time and just to explain why I'm doing something. Anyways, let's define chemistry. Chemistry is the study of matter and the changes it undergoes. So anything that happens to matter, and we're going to define matter in a second, so don't worry if you don't know. But anything that happens to matter is a change, and any change is a part of chemistry. And so we can see chemistry in multiple areas in the world. We can see chemistry undergone with non-living and living organisms. So non-living things and living organisms. And so when we study chemistry that has to do with living organisms, this is known as biochemistry, where we're studying the chemistry of life. And last year in biology, we focused a little bit on that when we were talking about cellular respiration, photosynthesis, just the breakdown of anything. Any change in matter, any change in compounds, that is chemistry. So I liked this definition on this picture because it says chemistry deals with the study of elements. So basically atoms, molecules, compounds, and their chemical compositions, characteristics, structures, and reactions. So this definition is just a little bit longer, a little more specific on what we're looking at. But the big deal here is that any change in matter, and matter can be categorized, and I have a nice chart actually on the next slide I'm going to show you, but we can categorize matter based on the properties that it exhibits. So if I have a substance and I don't know what it is, I could test to see what it is based on the color, the smell, the density. Any property that we could measure is a way to identify a chemical substance. Again, just to mention that chemistry is involved in multiple realms. Anything that's invented is based on chemistry. And sometimes good inventions are all happy accidents that happen in a chemistry lab. One really good example is like Kevlar vest. Just a happy accident. Other ones are like things like nylons, happy accidents where we just looked at the physical and chemical properties of a substance and then manipulated it to make it usable. And then somebody capitalized on it and they became a millionaire. So that's a great thing. If you want to be a chemist, make sure you go into the private sector where you can make a lot of money. Okay, this is where we're going to spend the bulk of our time. So you're going to be looking at this screen for quite a while. First, let me define matter to you. So remember, chemistry has anything to do with changes in matter. And matter is anything that occupies space and has mass. So anything that you see sitting around, that is matter. Anything that occupies space and has mass. So this includes things we see which is known as macroscopic, and things that we do not see, which is known as microscopic. So atoms, elements, compounds, those tiny components that make up something else those are the microscopic things, whereas the macroscopics are the things we see. So for example, a bottle of water, you see the water, that's the macroscopic view, that you actually see the water in the bottle. The microscopic view are the compounds that are all compacted into that bottle to help make that liquid form. And we are going to spend time talking about solids, liquids, and gases as well when we start talking about matter. And that's going to come up when we start talking about the changes that matter can undergo and the physical properties. So how do we categorize things? I am talking very fast, so I'm going to try and slow down. I'm going to take a deep breath. So like I said, we can further categorize matter based on the compositions and the properties that it shows. And so there are two categories, and I'm going to go ahead and grab my pen. Like right here, we have matter, and we can further categorize it based on pure substances and mixtures. So I want you to take a second, and I want you to think, when you hear the word pure, what do you think of? Like, why? I'm not trying to make it sound like anything special, but what makes something pure? And so I want you to think about that as we go through this, because when you're categorizing things in class, I want you to remember, when you think of the word pure, what makes something pure? And so you'll see here that this nice little diagram does a really nice job at showing and just breaking these words down a little bit more. So again, I said matter can be broken down into either one, a pure substance, or two, a mixture. We only have one type of substance present. That is a pure substance, where this substance is completely the same throughout. That if I were to pour some water into a bottle and then I took that bottle and poured it into a cup, I know that I'm always going to have water. Other things about pure substances is they hold their own properties. They have their own distinct properties that makes them who they are. So we call this definite composition and distinct properties. That is the definition of a pure substance, where it cannot be anything else. It is made up of certain things, and that's the directions for it all the time. So in order to make water, I always have to have two hydrogen atoms and one oxygen atom, and they have to be bonded together, and that's a water compound. That's always the ingredients to make water. That's a pure substance where you cannot even modify it at all, or it's not the same thing. For example, I could say, any compound that's made of hydrogen and oxygen is the same compound. That's not true, because I could make H2O2, which is hydrogen peroxide. Hydrogen peroxide is much different than water, H2O. So again, a pure substance has its own definite composition and distinct properties, that we can test those properties and be able to say this is this compound or element. The other thing I wanted to make sure I made clear is that these are not broken down physically. You cannot break a pure substance down physically. Now, so you're probably thinking, well, I can just take a piece of gold. It's pretty dense, or not pretty dense, excuse me. It's pretty easy to melt down. Yes, that's a physical change, but it's not changing the actual gold. For example, if I take a pure gold block and I melt it down, I still have gold. And then I can take that pure gold block and make other things. So I physically changed it, but I did not chemically change it. Pure substances, once they become chemically changed, they are not the same thing. Now, we can break down pure substances between elements and compounds. And you'll see in your notes that I kind of messed up where I was putting that stuff. So I have a big sign that says, write this under pure substances. So with elements, we have approximately 118, and some of them are man-made, but for the most part, they are all naturally found on the earth. We distinguish elements using chemical symbols. And we're going to add this to your notes because I did not add this in and I just feel silly. A chemical symbol is used to indicate each different element. So every element has its own chemical symbol. The other thing I want you to understand is that elements cannot be further divided down, and they are made up of atoms. So for example, hydrogen, the element hydrogen is made up of multiple hydrogen atoms. but we can't break that down. So you'll hear elements and atoms kind of interchangeably used. I do that quite often, and I don't mean to, and it's not that I'm saying that they're the exact same thing, but because elements can't be further broken down and they're made up of atoms, it kind of like, yeah, it kind of just sounds a little funny. The next one, elements are broken down into compounds as well. So a compound is just a little bit of a step higher than elements, where it's composed of atoms of two or more elements chemically united. So we have all of these compounds that we have, such as water, hydrogen peroxide, table salt. Any compound that's chemically combined is a compound. Now, we're going to talk about this a lot more in class, and we're going to spend quite a bit of time just making sure you understand that chemically combined means that we are now making a brand new compound with its own properties, that it does not act like its parents, if you will. So for example, I have H2 and I have O2, and they can combine with a lot of heat. They can combine to create H2O. And I know you're thinking, well, where did that other hydrogen go? Well, it's just floating in space and it bonds somewhere else. But the point is that I made that water. I could also take H2 plus O2 and do something else to it and make H2O2. So these are both using hydrogen and oxygen, but they are chemically combined, and now they have their own distinct properties. The parents would be H2 and O2. This is a mess, I apologize. The parents are H2 and O2, but when under different circumstances, they become different compounds. And this is important because then we're making different compounds that have their own properties to them. I'll go ahead and erase because this is a little bit of a mess. I'm sure there's like a way I can erase the whole thing at one time, but it's fine. All right, so the next thing I wanted to mention, now we've talked about matter being broken down into pure substances, where these are the definite composition, they're made very specifically, they cannot be changed. Now let's talk about how matter can be changed, and we're going to talk about the more common type of matter, which is known as a mixture, over here. And a mixture is more than one type of substance present. And what's great about a mixture is we can physically combine these things. And so most of the things we deal with on a daily basis are just mixtures of pure substances. For example, I can take salt water, I can take some salt, and I can put it in a cup of water. I have salt water. Now, I could make more salty water or less salty water. So it depends on how much salt I put in, but we're still mixing it up physically. So that's what makes a mixture different from a pure substance, is my amount or my ingredient list can be modified and changed. We can break down mixtures between homogeneous and heterogeneous. Homogeneous is where it looks all mixed throughout. So if I were to take some salt water and mix it into a cup of water, it looks all the same. Probably looks a little cloudy, but it doesn't look very different. It's a little harder to separate a homogeneous mixture, but I can separate it. That's another big distinguishing thing between mixtures and pure substances. Pure substances cannot be physically separated, and they cannot be chemically separated. Once they become chemically separated, it's a brand new substance. Mixtures, on the other hand, can be physically separated, and you hold the properties of the substances mixed. So for example, again, let me use salt water. If I take salt water and I boil it, I can easily trap the water to catch it, and it keeps its properties as water, and I have salt at the end. Neither one of them have changed. Still, both hold their components or hold their properties of those individual components that made the mixture. The second type of mixture we have is a heterogeneous mixture. Heterogeneous mixture is an irregular composition where we can see the differences in it. And a good example is trail mix. If I have trail mix and I don't like the raisins, I can pick the raisins out. That's a really good example of a heterogeneous mixture. Now, I have said so much information on this slide, and I don't want you to get overwhelmed. We're going to spend a lot of time talking about this. We're going to make a chart and put this in our notebook as well. What I am going to let you know, though, is we are going to add a little bit of notes here. In my notebook, it's one full page, so I would go ahead and keep the back page empty because I want to add quite quite a bit when it comes to, I guess not quite a bit, but probably like half a page for elements and compounds, and talk more about the mixtures, giving you more examples. I don't think I gave enough in the notes. So please leave some space to add for Thursday. If you have any questions, please make sure to ask me on Edpuzzle. I hope this is not confusing. I realize I'm talking very fast, so just let me know. Thanks.